Hey team, it's Mr. Z, and today we're going to review how to factor using a slightly different method. Let's go ahead and take a look. So we're going to factor each expression using the chunking method, and basically the chunking method is when you see that there is a square in the first term. And what I mean by that is I see 4x squared, and at first look it might just seem completely normal, but I notice that it has a square property, has two identical factors and multiply to be it. You could think of it as the square root of 4 is 2, the square root of x squared is x. But essentially, we're going to look at terms in 2x and 2x. So why does this matter? Well, let's try to rewrite our problem. So this first number, 4x squared, you're going to just trust me. I'm going to rewrite it as 2x times 2x. Then I need to add 8x. But I actually see that I can rewrite 8x to be 4 times 2x. I want to be frank. Where did these numbers come from? They are the same thing, but we're writing them out in factored form. We're using equivalent facts to swap. Okay, so we've rewritten our expression. Now, what we're going to do is we're going to let z equals 2x. I'm going to actually switch to color. Let's use... So why am I going to throw in a new variable? Well, right now, in its initial form, if I try to factor this, it wouldn't go so well. But if I let this chunking method work, it's going to actually take this problem into something I can factor. So 2x times 2x, well, if z is 2x, this is going to turn to be z times z plus 4 times z plus 3. This is very specific. Notice what happened. If I clean this up, z squared plus 4z plus 3. Now, we basically took our problem and made it a simpler one. This one will be able to be factored using our traditional area model. Z squared 3, I need to make a 4z, so notice how I was able to factor it. This is going to turn into z plus 1 times z plus 3. Now my original problem had x's in it, so I'm going to just now swap it back, and it's going to be 2x plus 1 times 2x plus 3. This is called chunking. It's whenever you see that the first term is a square. Notice in the second problem, 25x squared can be made by multiplying 5 times 5 and x times x. I see that same fact in 35x. I know 35 is divisible by 5. So I'm going to rewrite 25x squared to be 5x times 5x. I ask myself, what number times 5 is 35? And then I add 12. This is an equivalent expression. All I did was split up 5x. Now, whatever number you do split up is always going to be the one you replace. I use z because my last name is Zimmerman. So, let's replace the 5x's with z's. So I got z times z minus 7 times z now plus 12. This becomes z squared minus 7z plus 12. I see a quadratic instantly. You should want to factor it. I put my z squared, I put my 12. I have to figure out how to get negative 7z in both of these regions. So let's go ahead and ask ourselves, what numbers multiply to be z squared? Okay, easy answer. Z times z, only possibility. Now I need to get 12, but I need to get a negative. So like if I do just 4 and 3, that's going to be 4z and 3z, which will give me 7, but it's not negative. If I make one of them negative, it won't make a negative 12. So both have to be negative. Negative 3 times negative 4 is negative 12. And negative 4z with negative 3z ends up to be what I want. So this area model helped me factor it. I look at the sides, z minus 3 times z minus 4. Now I got to replace it with the more complicated expression. I have to replace my z's with what I said they were. Oh, this is going to be 5x minus 3 times 5x minus 4. This is called chunking. This is when you see a perfect square as your leading term, and then you see that factor in the second term. Hope this helped, team. Another technique in order to factor.